In this video, I want to go over the answers to classwork 10. So I'll start with part A. It says, let demand for a good be given by x1 is 10 minus p1. If p1 falls from $3 to $2, what is the change to consumer surplus? So I'll just kind of sketch what's going on here. So here's x1, and I'll have p1 up here. And I have a demand curve that I'll draw. I want to put it in the form y equals mx plus b. And notice that it's a convention to put p1 on the vertical axis, so that's what I'll do. Rearranging this so that I have p1 isolated. So I could subtract 10 to both sides and get negative p1 equals x1 minus 10, and then multiply it by the whole thing by negative 1 to get p1 equals 10 minus x1. So I have a slope of negative 1, and I have a y-intercept of 10. So my demand curve will look something like this. I want it to meet here. Okay. All right, so that's my demand curve. And I'll label this. We know this y-intercept is 10. So if this asks if the price falls from $3 to $2, so here's the price at 3. Make that a nice straight line. So P goes from $3 to $2. This is P at $2. What is the change to consumer surplus? So we learned that consumer surplus is the area under the demand curve and above the price out to the quantity demanded. So the yellow area is the consumer surplus before the price drop. And then I'll highlight in, let's do blue. This area is the consumer surplus after the price drop. And it's larger because the lower price benefits consumers, both because they don't have to pay as much for the goods that they're buying, and because they buy a couple more. So there's kind of two effects going on there. So this blue area, the whole thing is the consumer surplus after the price drop. And then this would be the change to consumer surplus because of the price drop. So to figure out the area of the blue trapezoid there, I'm going to take the area, the consumer surplus for $2, and I'm going to subtract off the consumer surplus for $3. So what is the consumer surplus under P equals 2? Well, it's a triangle, so it's going to be 1/2 the base times the height. The height, so here's 3, here's 2. The height of the triangle when the price is $2 is 10 minus 2, which is 8. So we know the height is 8. And then what is the base? The base goes from 0 to, I'm doing the $2 triangle, to this x1 with a price at $2. And what is that? I can plug in $2 to this demand equation, and I find that this is 10 minus 2, which is 8. I demand 8 units of good 1 when the price of when the price of good 1 is $2. So that's 8. So I get 1/2 of 8 times 8. Half of 64 is 32. The consumer surplus is 32 when the price is $2. What about when the price is $3? Now I'm doing just this green triangle. I again have the 1/2 of the base times height. Here, the height is the difference between 10 and 3, which is 7. And then the base goes from 0 to this, x1 when the price is 3. Put 3 into this equation, I get 10 minus 3 is 7. So 1/2 of 7 times 7, half of 49 is 24.5. 24.5. And then let's use a calculator to find the difference. So the price went from $3 to $2, and we go from having a consumer surplus of 24.5 to having a consumer surplus of 32. How much did the consumer surplus change? 32 minus 24.5. Our consumer surplus increased by 7.5, and the unit for consumer surplus is dollars. So $7.5 is the answer I'm looking for there, or $7.50. Okay, so that sums up part A of this classwork. Now let's go on to part B. Part B says there are 2 other important ways to measure changes to a consumer's welfare from a price change: compensating variation, CV, and equivalent variation, EV. When utility has a certain functional form, that is, it's quasi-linear, consumer surplus will be equal to the CV, which will be equal to the EV. Show that this is true using the quasi-linear utility function. U x1, x2 is the natural log of x1 plus x2. Let P2 be 1 and find the change to consumer welfare from P1 falling from 2 to 1. Some more details about CV and EV are below. So it's just like consumer surplus, both CV and EV try to measure how much better or worse off the consumer is made because of a price change. I'm going to skip this for now, solve the problem for consumer surplus, and then come back to discuss what CV and EV are. This hint is important though. So my first step will be calculating the demand functions for goods 1 and 2. My 2 unknowns are x1 and x2, and my 2 equations are that the marginal rate of substitution is the same as the price of good 1 divided by the price of good 2, and that the budget, so that's just that the utility curve is tangent to the budget line, the bundle of goods, the optimal bundle of goods, and the budget line is fulfilled with equality, or the budget constraint. You should find that x1 is this and x2 is this. These will be useful in all 3 calculations. So let's start there. Start with proving that this is our demand for goods 1 and goods 2 under this quasi-linear utility function. So I'm saying I have 2 unknowns and 2 equations. My 2 equations, I'll start out with this one. I know that the marginal rate of substitution is del U of x1, x2 over, I don't usually write the x1, x2 here, so it's just del U over del x1 divided by, so this stands for the partial derivative of U with respect to x2. That's going to be equal to P1 divided by P2. It's the first equation, and then the second equation is this. Just rewrite that. P1 x1 plus P2 x2 equals M. Let's take these partial derivatives. I know that utility U x1 x2 is this quasi-linear thing, natural log of x1 plus x2. So what is the partial derivative of this with respect to x1? Thinking of this as a constant, so I can ignore that. So it's just added on. And the derivative of the natural log is 1 over x1. So 1 over x1 divided by partial derivative of this thing with respect to x2. x2 just shows up here, so that'll be just a 1. That's equal to P1 over P2, and so I'll get that 1 over x1 equals P1 over P2 take the reciprocal of both sides, and I get that x1 is P2 divided by P1. Let's check to make sure that that's what I wanted to show, and it is. I showed that x1 is P1 over P2. That's the demand for good 1 given these set of prices. Now let's plug this in to our second equation, and hopefully we can find that this is true. So that's get P1. I'm going to plug in P2 over P1 for x1, P2 over P1, plus P2 x2 equals m. The P1s cancel here, and I'll just say, I'll pull out a P2. I'll say P2, 1 plus x2 equals m. Divide both sides by P2, I'll get 1 plus x2 equals m divided by P2. And so x2 is m over P2 minus 1. And that is exactly what we wanted to show here. Okay. So that's a pretty good start for us. That was our first step. So then I say, for consumer surplus, draw the demand curve as a plot of x1 against P1, and consider how much the consumer surplus changes given the price change. And then I have a hint about that. So let's add another page here. I just want a blank page. Plus, some squared paper. Okay, so I'm going to take this demand for good 1, that x1 is P2 over P1. And I think I say right here, I want to know, I'm going to let P2 be 1, and I want to know the change of consumer welfare from P1 falling from 2 to 1. So if P2 is 1, then that means x1 equals 1 divided by P1. That's our demand for our good 1. So let's bring that down here. I want to sketch that demand curve. So let's think about what x1 and P1 are for a couple of values. So let's take, I'll have P1 up here, x1 up here, and talking about the demand for a good 1. So what is P1, or what is x1 when P1 is 1, 2, 3, and 4? x1 is just the reciprocal of P1, so it'll be 1, 1/2, 1/3, and 1/4. And then what is x1 when P1 is 1/2, 1/3, 1/4? It's 2, 3, and 4. So let's plot that. Have 1, 1, that's this. I have 1/2, 2. So here's me at 1/2, and then 2. I have 1/3, 3. So that's 1/3, 3 there. 1/4, 4. Just keeps on going up like that. Getting closer and closer to this axis. And then I have 1/4, or let me start here. Here. 2 on the x-axis to 1/2 on the y-axis. So 2, 1/2, and then 3, 1/3, and then 4, 1/4. So on the side, and you can see it's like symmetrical about the y equals x-axis. Okay. So so that's what we want to know. Now we've got the demand curve. We got it sketched out. What is the change to consumer surplus when P1 goes from 2 to 1? That was our question, right? Yes. So here's P1 at 2. Here's P1 at 1. So we know that, again, consumer surplus is the area under the demand curve and over the price. So here's my consumer surplus at, the yellow area is the consumer surplus at the price of $2, and then the price falls to $1. And here's my new consumer surplus, all of this area. And so what I want to know is, what is this area in turquoise here? This area is the amount, is the change to consumer surplus I gained with the price drop. So this is kind of the tricky part. How do you find the area of this little segment here? And we can approximate it. That would be one way, because I know that like this is 1, 2, 3, this is 1, 2, 3. So it looks from here, and also I know that this occurs at 1/2, right? 0.5. So I know that I have, it's in between 0.5 is the change in consumer surplus, 1. In between 0.5 and 1, we know that, but I think we can get a little bit more precise. So I want to actually think about rotating this whole thing. I'm just going to grab this, copy, and then paste. What would it be like here if we rotated? Make it a little bit bigger. Keep the scale the same. Okay. So if this rotation didn't change any, anything about this, about the area of this shape. So I can go, this shape, I think maybe finding the area of this shape might be a little easier than finding the area of that shape. I know that this curve here is, we had 1 over x1. And so I'm thinking what I can do is I can find the area under the curve, the integral of 1 over x1 between x1 being 1 and x1 being 2. That's kind of my hypothesis here. And I know that the integral of 1 over x1 is ln of x1. Evaluate that from 1 to 2. We get ln of 2 minus ln of 1. Natural log of 1 is 0. So e to the 0 is 1. So I'm left just with ln of 2. I'm going to use r to figure out what that is. And r tells me that the natural log of 2 is 0.693. So that's our final answer. The consumer surplus changed by 0.693, and units for consumer surplus is dollars. And that fit our approximation, which is that the consumer surplus was between 0.5 and 1.